process of creating a triangle of forces is used to help us to find the angle between forces acting on an object. Or it can be also used to find the strength of these forces. There are a few things we need to remember. When a particle is at rest or it's moving only at a constant velocity, the sum of its forces or its vector forces is equal to 0 only in this case. The cosine rule and sine rules can be helpful here. And remember that forces are measured in newtons, or we use kgWt as shorthand. The force of gravity is always equal to the weight of the object itself, and gravity always acts directly downwards. Note here that the magnitude of a force is not the length of its vector in, say, centimeters or other units. The magnitude of a force refers to its strength in pulling or pushing an object. Here are our examples. We have 3 dogs that are pulling on an object in 3 different directions. I'm going to draw these dogs as vectors, all of them pulling the object in their own unique direction. They do this such that the resultant force on the object is 0. This means our object is at equilibrium, or that we can use a triangle of forces here. The first piece of information we have is that the first dog acts at an angle of 150 degrees to the second dog. Let's draw this in. I'm going to call dog A and that force vector A. Dog B and his force can be vector B. These 2 forces are at an angle of 150 degrees. We also know both of these forces, so the magnitude of vector A and the magnitude of vector B are the same strength, and they're both 20 kgWt. We don't know much about the third vector, so let's just draw it in, perhaps diagonally down to the left. Our job is to determine both the magnitude or strength of the force being applied by the third dog, so the magnitude of vector C in kgWt. We also need to find the angle that the second dog makes with the third. So if we let the angle between vector A and B be alpha 1, the angle between vector B and C be beta 1, we are trying to find beta 1 in this question. To be able to do both of these things, I'm going to have to draw my triangle in. I'm going to start with vector A, then I'm going to add on vector B to the end of it, and then finally I'm going to add on vector C to the end of vector B. Notice here that they'll touch and create our triangle of forces. We can also add in that the magnitude of A is 20, the magnitude of B is also 20. Because we know that alpha 1 is 150, if I let alpha 2 be the corresponding angle between A and B in my triangle, the same with the other angles, make sure the angles in your triangle correspond to their location in the original diagram. So beta 2 will be between vector B and C, and gamma 2 should be between vector A and C in the triangle. Like I said, because we know that alpha 1 is 150, and we know that alpha 1 plus alpha 2 equals 180 degrees, this means alpha 2 plus 150 will be 180. So my angle alpha 2, or that angle between A and B, will be 30 in the triangle. Once you've got all the information into your triangle that you can, we can start to use the triangle to find our unknowns from the questions. Let's start by actually doing part B first. I'm going to find the angle that the second dog makes with the third dog. So by looking at my triangle, I can see something very important, that this triangle is isosceles. Vector B has the same magnitude as vector A. This means angle gamma 2 will be equal to angle beta 2. And if I can find angle beta 2, I can also find angle beta 1, which is what the second part of this question is asking. Using the angle sum of a triangle, I know that beta 2 equals gamma 2, and that will be 180 minus 30 over 2. When we simplify, we get that this is equal to 75 degrees. Now, because we know what beta 2 is, we can say that beta 2 plus beta 1 equals 180 degrees. When we use this fact, we get that beta 1 is 180 minus 75, or 105 degrees. So that's part B of the question. And remember that I'm applying this to the original diagram. Let's now go back to part A. Determine the magnitude or strength of the third dog. Because I have more angles and more sides in our triangle, we have to have a think about, how do I find the magnitude of vector C in terms of its force? Can you use the sine rule or the cosine rule? Do the one you hate the most. I'm going to do the one I like the most, which is the sine rule. Find your opposite side and opposite angle. I'm going to use vector C because that's what I'm trying to find the magnitude of, and its opposite angle 30, as well as vector B and its magnitude of 20 with the opposite angle of 75. In this way, we can write 20 over sine 75 is equal to the magnitude of C over sine 30. If you do this, you'll get an exact form of 10 root 6 minus 10 root 2. If you're asked to round it to 2 decimal places, this will be approximately 10.35 kgWt. And remember, life has its own hidden forces, which you can only discover by living it.